So, okay, so you got your water flowing from the tank at the bottom of the cone, and I even added this cone down here, which is kind of cool. See, the cone's full. The radius and the height are changing as the water spills out. So that's what we're asked to do, is deal with how the radius is changing, or how the height is changing as we go through this. If you read the question, it says, we have a cone that is 6 feet by 12 feet, and water is flowing out of the bottom at a rate of 6 cubic feet per hour. At what rate is the depth of the water in the tank going down when the depth is 4 feet? So we just need to go through and write down everything we know and the things we need to know. So what do we know? What do we know from up here?
The entire tank is 12 feet.
All right, so we know the height is 12 feet. What else do we know? The radius is 6. And what's going on?
The rate is 6 feet.
What rate?
The water is -6.
Yeah, the change in volume with respect to time is -6 feet, cubic feet per hour. You guys realize this is a ginormous cone, 6 feet by 12 feet? Yeah, just saying. Anyway, what's the volume formula for a cone?
equals pi over 3 times height squared. No.
What's the,
Third pi r squared times height.
1/3 pi r squared times the height. Okay, so then what do we need to know? Oops, I got a half, sorry. I will fix that and make it a third then, since that's, oops, and I mixed up my 2 and my 3. I made the radius a cube, sorry. It's the end of the day.
Did you notice the homework problem? It was talking about the rate of change of the snowball that you're going to throw at your teacher's head.
Oh, yeah.
Like, the radius is 2 feet.
Yeah, you're pretty much going to kill the teacher.
Just a 4-foot diameter.
Yeah.
Snowball you're going to throw at your teacher.
So what do we need to know? What do we need to know?
We need to know what the rate is, or what rate is the depth of the water in the tank going down.
So we need a rate, we need a something over dt. Which one are we going to use, dr dt or dh dt? So dh dt is our height that we're the change in height that we're trying to find, the change in depth. And so then when do we want to know that? So when the height is 4 feet. All right, so we're dealing with that. And so the question is this: if I look at my formula for a volume and I was to differentiate it, this right here becomes a little bit of a problem. The r squared h, because r squared and h is a product, we'd have to do a product rule in order to differentiate that along with the chain rule, which gives us the dr dt dh dt, which we really don't want. We want it in one variable. So we're going to have to transfer this into one variable, and since we're looking at dh dt and h, then we want to get rid of r and figure out how r is related to h. And this is typical for all of these problems. If you get an equation that has more than one variable in it, your job is to remove the unwanted variable. Does that make sense? Yeah, all the other ones are easier because, right.
I think these are the only ones with 2 variables.
Yeah, it depends. I mean, there's other ones, like the Pythagorean theorem ones have more than one variable and stuff like that. So you just, yeah, some of them are easier to get rid of than others. This guy, you have to use similar triangles. So I have a triangle for the cone itself, which is 6 by 12, and then I have the water triangle, which is h by r, which we don't know, because we don't know where. I mean, we know h is going to be 4, but this is in general versus that specific. So we just go through and set up these are similar triangles, because we have 2 angles that are at least the same, and so then we can go like 6 over 12 is equal to r over h. And with that, then I can solve for r and say 1/2 h is r. Now I can replace all my r's with that right there. So into this equation, my r squared will turn into 1/4 h squared. You with me on that? So if I turn that so if I go ahead and substitute it in, my volume equation is now 1/3 pi times 1/2 h, whole thing squared, times the h that was originally there. Which then, simplifying this, gives me basically 1/12, because it's 1/4 times a third, pi h cubed. So now we're in a good spot, because everything's in one variable. So now if I differentiate this thing, I'll pick up the dH dt, which is what I'm looking for, and everything else has a variable that can be substituted in. And so if I did that, then I'd say, oh, okay, so I get dV dt, sorry, Brian. And then if I multiply by 3, that turns into 1/4 pi h squared dH dt. He's like, why is it not writing? I can't.
Kind of see it because it's a darker shade of whatever.
I actually have trouble seeing that.
Okay, well, sorry, I don't,
No, that's fine. I just can't tell you what, I have no idea what color that is.
it is red.
Definitely red.
So with that, and then I can go ahead and I have 1/4 pi h squared dH dt. H is 4, dV dt is 6, so I just plug in -6 equals 1/4 pi times 4 squared dH dt.
Wait, so it became, whoa, I missed a part.
All he did was,
So once I went here,
VD.
I differentiated.
Oh,
And then from here, I then substituted.
okay.
That's all I did. So this was differentiation 1/12, the 3 times the 1/12 gave me 1/4, pi r h squared dH dt, substitute in, now I have to solve for that guy.
Okay.
And so it basically becomes 16 times 1/4, which is 4, so I get -6 times 4 pi dH dt. And if I divide it across dH dt, comes out to be -3 over 2 pi, and that is
It's like algebra, just dividing.
feet per hour, yeah. So really, it's losing about half a foot of water. The height is going down by about a half a foot, because this is about 6. So it's losing about a little over a half foot of water every hour, is what's going on with that.
These are like the hardest ones.
These are some, yeah, these are the ones that are going to show up on the AP test.